Okay, guys, welcome to Module 10 of Network Security Fundamentals series, where we're going to be discussing the cloud and virtualization security, the new technologies, new emerging technologies of cloud, and previously virtualization coming to our world actually are bringing in more concerns about security, especially considering the distributed nature of cloud computing. So hopefully by the end of the module, you should be able to define the cloud and explain how it is used and managed, explain virtualization, describe cloud and virtualization security controls, and finally list different secure network protocols, which we're going to visit at the end of this module. Okay, so what is cloud security altogether? So in order to understand what cloud security is, you first need to understand what cloud computing itself is, right? Also, you have to understand the steps to take in order to secure the cloud computing environment. So in the old days, if you have seen any of those old day diagrams, whenever the infrastructure and the computers included in that infrastructure were not a concern of the architect or the designer or anyone who was using the diagram. They were just drawing a cloud and putting everything in that cloud, right? And you have seen all of those diagrams from old days. That is actually the origin of the terminology cloud computing. So anything, any service that you receive in computer world that you don't care about setting it up, you don't care about maintaining it, you don't care about managing it, is basically falling under the umbrella of the cloud computing. And these are usually also called hosted services. And in those environments, you can have servers, storages, networking devices, and those can be used by one enterprise or multiple enterprise, depending. Can you guys please mute yourself? If you're not talking, guys, please mute yourself so we don't get disturbance in the video. Okay, cool. Thank you. So cloud computing itself is a model for enabling environment on-demand network access to a shared pool of configurable computing resources. So entities that offer cloud computing are what we call CSP or cloud service providers. Well, big names in cloud service providing are Microsoft provides that, they have their cloud, Google provides that, Amazon provides it, and we do have Salesforce, SaaS, and all of those goodies that play and contribute towards this environment, right? The money saving that you have through using of the cloud computing usually is the first reason for moving towards the cloud, right? And what happens in the cloud is you only pay for what you use. So think about it as a utility service that you have connected, right? You are connected to the unlimited, let's say virtually unlimited pool of electricity providers through PG&E network, which you can draw power from as much as you need. If you draw, let's say 4 kilowatt hours, you only pay for 4 kilowatt hours. If you draw 200 kilowatt hours, you pay for that 200 kilowatt hours. The difference is if you purchase, let's say in the computer world, if you purchase a computer, you pay for the entire hardware and the software associated with that hardware, which you're going to bring home as your personal computer. And no matter what, that's your computer. It's not going to easily upgrade. It's not going to downgrade. You already have paid for it in full. And if you leave it there and not use it for about 4 or 5 months, as you know, most of the items that you have in that computer are going to be obsolete after a couple of months, and they're old already, right? That's how fast the technology moves. And if you haven't used all that capacity, basically your money has gone in vain. Some people go and buy a super duper gaming computer, bringing it home, set it aside, play a couple of games on it, and then forget about it for a long time before they actually go back to it, just to figure out the newer games they want to play are not compatible with that computer anymore because that is old. What cloud gives you is cloud says, okay, you know what? You want to play a game right now? Come in and use all the resources you need and only pay for those per minute or per day that you use them. And when you don't use it, just scale back to a very, very minimum computing device and just do your schoolwork on it. So when you do your schoolwork, you're going to pay less. When you do the gaming, you're going to pay more, right? One of the attributes associated with cloud computing is this scalability, right? And elasticity, the fact that you actually can use more resources whenever you need and downgrade back to the minimum that you want to pay for when you don't need it. Think about an example. If you just developed a website to provide a specific service to your customers, and you only have 10 to 15 customers, you possibly don't need a lot of processing power behind the scene of your website. As your business grows, you're going to need to have more processing power. And the traditional design, in the traditional model, businesses used to buy a server, install the server at, at their location on-prem. And after a while, when they needed more power, they were adding another server, and so forth. And then that was necessitating the presence of an IT specialist. Now you have to pay for that IT specialist to take care of the hardware. And as you grow bigger, you're going to have more and more concerns. What cloud give you is, at the beginning, you pay for what you actually use, the processing power you use. And then as you scale up, you're going to go to the higher tiers and actually just pay for the extra that you need. And that's going to save you money. Also, the elasticity of it allows you to have a cloud service, have a, let's say, a computing service that can scale up at the peak hours when you need more, and then automatically scale down when you need less. The fact that you pay per use gives you a very good opportunity to be able to manage your budget on a work that you may not even know how it's gonna scale in the future. Also, the cloud services are on demand, means they're available to you when you need them. And when you don't need them, you can simply just discontinue them or turn them off and not paying for them. Nowadays, you can have this, let's say, virtual machine spawn up in Microsoft Azure Cloud, and you can just turn it on. And as soon as you turn it on, you start paying for it, do your calculations, do your computations, do your database maintenance or whatever you need to do, and then turn it off where you will not be paying anymore for it, as if it doesn't exist, right? So it is available to you on demand. And then, because you're in the environment that is being maintained by somebody else, they take care of your business continuity. They take care of your disaster recovery. So they have backups of your data. They have multiple servers available to you, multiple server services, right? Available to you in the background, that in case of a mishap, it can actually take over smoothly and seamlessly. So your customers don't even notice that a change in the server has happened, right? Some of them even use different regions in the world. Like if you look at the Microsoft Azure or AWS from Amazon, they do have different redundancy regions in the world. Like they have your main server in United States continental area, and then they have your backup server for disaster recovery located, let's say, in South Africa. And the third one is located in, I don't know, you name it, Korea, right? So in case of a mishap, and let's say if an earthquake happens, if a catastrophic event happens in the continental North America, then you'll still have a server in South Africa that has a backup of all of your information. So that gives you a resiliency and reliability that normal on-prem systems really don't provide. So looking at this slide, you can see that you have an on-prem system, right? You have this on-prem system, the enterprise LAN, whatever computer you have, which connects you to the cloud vendor that's provides services to you. So this is a kind of like hybrid design where you have your on-prem system and in-cloud system working together. Usually there are technologies to make sure the communication is secure, the connection is secure, and so forth. We're going to discuss about those more. But the whole idea is your on-prem enterprise system is connected to your cloud system, and you can use them for some services, and you can use your on-prem for other services. There are some specific mission critical tasks or activities that some of the enterprises don't like to hand over to cloud because of the lack of 100% control. When it comes to cloud, you're at the mercy of the cloud provider, right? If they're secure, you're secure. If they're not, you're not, and so forth, right? If they are able to manage everything, then you're in good hands. If they're not, then your cloud service may not be of the highest quality ever. So for that reason, some of the enterprises still maintain their on-prem network on-prem system, right? Where actually can act for specific needs. Some of which may even be compliance, right? Like, let's say you are at the doctor's office that according to the compliance so-and-so, they need to keep some files on-prem and not share it with anybody, even a cloud provider. Of course, most of these like HIPAA for insurance and all of these kind of compliances that are out there, they have requirements that in the early days of the cloud, they were not really doable and the cloud environment, because we didn't have that level of sophistication, like that level of encryption and all of that are the requirements of the compliance rules. But nowadays, almost all cloud computing services provide granular settings that you can go in and put the settings in for specific encryption to be in compliance with HIPAA and all of that, which that enables enterprises to fully move into the cloud. So in the cloud architecture, you are a client, and the client has a computer that runs from resources stored on a central or distributed cloud server or a cluster of servers, right? Then you connect to the cloud system. You connect to the cloud environment. In case of an Amazon cloud, the EC2, right? You have to use, just learn the terminology, a transit gateway, which is a technology that organizations use to connect to their VPCs. So their instance in the cloud is called virtual private cloud, or VPC, right? VPC is getting connected to the physical data centers, remote offices, and any kind of remote network appliances that you have. So this example that we see here is for AWS, but you can have it for the Azure, and you can manage it through the Azure portal. Each one of the cloud providers has its own way of providing access. But at the end of the day, there's always a gateway. There's always an entrance point or an API that basically vets the users for identification, authentication, and authorization, or even accounting at the end. So IAAA basically that takes care of this connectivity between on-prem or even just one computer to the entire virtual environment. When you're using cloud, you basically are in a serverless infrastructure, which is one in which the capacity planning, installation, setup, and management are all invisible to the user. Remember, that's the goal of the cloud computing, to remove the IT requirements off of your plate. So you should not be dealing with which CPU to choose, which router to choose, which switch to choose, how many virtual machines to choose, right? You should be able to kind of like go all in and have a self-service system that you go to the portal and say, hey, I need this, this, and this, just check mark your requirements. And then all the capacity planning and everything happens by the cloud provider, and they are going to put the instances in place. If you want to think of cloud providers, think of this huge buildings with rows and rows of servers that are all connected to virtualization tools, which we're going to talk about later down in this discussion. And those virtualization tools are actually providing the necessary resources to any client, and they take care of how to share these resources between the clients and such. The biggest contractor in the United States is DoD, Department of Defense, right? So almost everyone in the business goes with the definitions that DoD puts in place. This terminology is not like super sharp, right? It's not like the boundaries of this technology definitions are not really like a fine line that you can draw and say, hey, you know what? Besides this point, it's a totally different service name, and before that is totally a different service name. But let's learn some of the concepts and some of the most commonly used terminologies, which is the first three that you see on this slide. First is a software as a service, or a SaaS, right? Vendor provides access to the software application running on a cloud infrastructure. In this case, you don't care about the virtual machines, you don't care about the operating systems, you don't care about the application installation. You just receive the service in front, right? Think of Netflix streaming, right? That is a software as a service. So basically, you just sign up for that cloud software as a service access, and then after that, you just browse through an interface which is provided to you. You have no role in designing that interface, right? You go in, choose the movie or video you want to watch, click on it, play. There are some controls for you, and you watch it without even thinking about underlying infrastructure, the protocols used, and all of those goodies, right? That's one good example of a SaaS. Also, there are websites that you go in, and the website has an application that takes care of a task for you. Let's say even the single sign-on that is provided by Facebook. The fact that you can sign in to different services through your Facebook account, the single sign-on is also a SaaS, but this is a good segue to mention what I earlier said about there is no fine boundary. You're going to hear the terminology that's called, they call it sign-in as a service, right? Which is basically a SaaS service, but they just want to make it a little bit more granular, right? Or authentication as a service. You're going to hear a lot of these names in the cloud environment, right? DoD limits it to SaaS, PaaS, and IaaS, which, to be honest with you, you can categorize everything else under any of these three, right? Like sign-on as a service can be a software as a service, right? Anyway, next one is platform as a service, where consumer installs and run their own specialized application on the cloud computing network. So basically, they provide the platform, meaning they provide a virtual machine to you, and then they provide, let's say, a bunch of virtual machines to you, which are connected to each other, already talk to each other, and you just install your applications on those platforms. So platform is the combination of the hardware or virtual hardware and an operating system. So let's say you just get the service, a virtual machine that has Linux, has Mac OS, has whatever, let's say Ubuntu, whatever, just name it. And now you can install your applications and all that. The cloud service takes care of the virtual machine updates, patches, vulnerability management, and all that, and you take care of the application. So this is kind of like a shared responsibility model in which you and the cloud provider are actually sharing, in the sense that application is on your shoulder and the platform is on their shoulder. So it's one level below the SaaS, because in the SaaS, the application was also vendor's responsibility. And then finally, you come to the IaaS, or infrastructure as a service. which the vendor allows you to deploy and run your operating systems, applications, and all of those together. So they just provide the hardware for you. You can even choose which switch you want to have between two computers or two portions of your network. You can segmentize a network within their environment. All in all together, just consider they're providing just the hardware to you. So if you look at it from the YAS up, it's only hardware, then hardware and operating system, and then hardware, operating system, and application. So that's the way it is. I really want to kind of like do this, so this one stays away from those. So anything as a service or a SaaS is the new definition they came up with. This is not the DoD definition, by the way, it's industry definition, which is a broad category of subscription services related to cloud computing. As the name says, you can call anything a SaaS, right? I personally don't like this one, but since CompTIA exam is going to refer to it, we want to just include it in here. But at the end of the day, again, remember, you cannot really draw a line and say what the service that you're receiving exactly is. Just you need to understand the cloud model better, which we're going to talk about it later down this discussion. So when it comes to management, cloud management can be conducted by the local organization, which is you, or by contracting a third-party management service provider. Like a small moms and pops shops usually go and find these local IT stores that they provide cloud management for them, and they take care of the technology. But at beginning definition of cloud computing was really emphasizing on the term self-serviceable, meaning that you should be able to take care of everything, like as if you walk into a buffet and just serve yourself, pick up everything that you want to eat, go sit down, and then leave the dirty dishes at the kitchen bouquet and move out, right? But nowadays, for those who are not really tech savvy, you can get that third-party management. Or if that's a big company but doesn't have any focus in tech, still you can hire third-party vendors. What I noticed in California is, because I was dealing with this problem, a lot of car dealerships, the small car dealerships that they sell the used car, they use these third-party management service providers to provide them IT services, even when they're fully in the cloud. So service integration attempts to achieve a boundaryless approach, which involves integrating all users across the enterprise who are using the computing. So we want to integrate everything to just one single service, which includes a single sign-on, single access, single accounting, single authorization, and all of those goodies. That's the model that a lot of companies are relying on. These days, Microsoft Azure provides Active Directory as a service. That's another flavor of the models we just discussed, right? Which is literally, again, a software as a service, but Active Directory as a service is making you, without any need to have an AD server, Active Directory server installed on-prem. So that Azure service can take care of all the authentications and all the logins that your users have to different services, whether cloud or on-prem services. So when locally managing cloud computing, an enterprise should have a written resource policies in place. Of course, you need to have the guideline and policies in place so that those outline who is responsible for cloud computing, what are their duties, responsibilities, how cloud computing can be used or cannot be allowed to be used, or the processes for acquiring the resources. Most of the greater companies, enterprises, they do have infrastructure and cloud department within them, which takes care of that. So it usually is combined with the infrastructure department. And then usually they have something like a cloud center of excellence or something included in that department that takes care of all of these. usually comprised of people who have the knowledge of major players like Microsoft or Amazon or Google. So a managed service provider, MSP, delivers services through ongoing and regular support, as well as active administration of those resources. This assumes the role of traditional on-prem IT organization. Sometimes you can just totally delegate this to the cloud service provider, and you don't need to have anybody on-prem or actually physically working with you on that. So now, since our focus is security, let's talk about the security issues that cloud computing brings along. First and foremost, unauthorized access to data, right? So improper cloud security configurations can result in the data being left exposed. Remember, at the end of the day, even within the cloud, the data should reside on a physical memory, on a hard disk, on an SSD, on a tape drive, something, right? Which data space may, if not configured properly, may be shared with another enterprise's information repository. Remember that we are in a shared environment, right? This is what cloud computing is all about. It's a shared environment. The virtualization actually has the role of providing that, that virtualized interface, which then shares everything, right? So underlying software is shared, underlying hardware is shared. So what if somebody can run a crawler to move from the section of hard drive that your code is on to the section that my code is on and read the code? Data exfiltration can happen and such, right? So we need to have proper configuration so that we stop unauthorized exposure. Some of the enterprises even require the cloud service providers to go ahead and just choose a specific physical and geographical region for their information to be stored. Like they say, our customer information should not live United States at all. All your servers in the cloud environment that maintain our info must be in the United States. Next is lack of visibility. So organizations have limited or no visibility into the security mechanisms of the cloud provider and thus cannot verify the effectiveness of security controls. So a lot of time, we do have security controls, the known security controls that are usually used in order to secure the cloud. And we're going to discuss those very soon. However, how can you verify if the cloud provider is actually implementing those and they're in compliance with the requirements that they say they are, right? That's the problem of visibility. We don't have visibility into the control implementation most of the time, especially as the small customers, usually cloud providers don't provide such visibility. So next is insecure application programming interfaces. An API is basically an abstraction of a service, right? Think of a car that you drive. You drive it through using the steering wheel, paddles, and gear shift stick, right? And all of these together are what comprise an interface for you, which enables you to drive any car that you have never seen before. But just know that you have to send this command. This interface is equivalent to the API on an application. So if there is an application that multiple users are using it, an API provides methods and functions that a user, a client of that code, which usually is another piece of code, right? Another application that is developed to fetch and call and therefore invoke a specific task within that application, right? So those are very useful when you want to develop something in cloud, right? However, a vulnerable API, an API with a specific known vulnerability and weakness can exploit the entire system to, can expose the entire system to the bad actor, right? So next is the compliance regulations. Maintaining compliance requires that your organization know where the data is, right? And how to manage it. If that is patient data, insurance data falling under HIPAA, or if that is credit card information falling under Sarbanes-Oxley or PCI DSS, any of these regulations, right? It needs for you to know where the data is, who accesses, and how it is encrypted or protected, right? But this is going to be a little bit difficult in a cloud system, right? Because you don't have that level of transparency as I talked about earlier. So finally, the system vulnerabilities. A cloud infrastructure is prone to vulnerabilities like any other system, right? It's a complex network. It's at the end of the day, it's a data center. It's a huge data center with many, many servers, physical servers in place, right? And usually multiple vendors are involved. Like they buy the main boards from Asus and then the hard drives from Dell. And then they buy, different pieces, and different applications are coming from different vendors. And that makes the network really complex. And if the vulnerabilities are not addressed the exact same way that a network can be compromised, a cloud system can be compromised. So don't think because it's cloud, then everything is good, right? However, we can put controls in place, and some of those are like conducting audits. It usually happens through an independent third-party vendor that looks into the controls, goes through if those controls are properly in place and how they are being respected and all that, right? You can use the regions and zones, which are actually the geographical regions and zones, and are used for reliability and resiliency. And what you can do is you can make sure your information is in the region or zone that you want it to be. So let's say, just think about this. If country X has a bunch of servers from cloud computing service A, which is originated in country Y, and all of a sudden country X and Y walk into a war, now the government of country X can confiscate all of the servers and open them up and look into the information that your company from country Y has stored in there, right? What if the cloud servers of Ukraine were located in Russia now? And now Russia can easily look into their information, if that makes sense, right? I'm trying not to be specific for the examples, but this makes life so easier since the conflict is going on right now. So secrets management. Secrets are basically the licenses and keys that we discussed before. Like remember when we were talking about the public key infrastructure and private key infrastructure and any kind of encryption, we talked about licenses, ciphers, keys, and all of those. In the cloud environment, we call them secrets, right? So through the secret management, you can enable a strong security and improve management of a microservices-based architecture as a cloud, allowing the entire cloud infrastructure to remain flexible and scalable without sacrificing the security, because you are implementing the same concept that we had for cryptography, right? Now let's talk about functional area mitigations, right? So you can enable and enforce these features: limited and automated replication. Make sure that the replication doesn't happen over all of the global resources that you have, right? And the secret data is stored in a specific region, which then user can specify, or the cloud provider can designate to user to be in that region. Have secret specific versioning. So basically make sure you always are using the latest and best version of your secret. If anything, just rotate those and upgrade those and change those for a specific period of time, making sure if the secret is compromised on the next rotation, it's not going to be available anymore. Audit logging, use encryption. The default encryption with most of the cloud environment these days is at least 256 bits encryption. Most of them are even moving towards 1024 bits of AES, but at least go with the highest that they have. Of course, the higher in the encryption you go, the more money you have to pay. It's going to be more expensive because cloud charges you for whatever you use, right? But when it comes to security, and we talked about the triad of CIA, you have to decide how much your confidentiality is important and how much does it worth to you. And then finally, extensibility, right? So one system is able to extend and integrate into other existing secret management systems so that you can combine these and make it even more difficult for a bad actor or attacker to get into it. Application security. So you do have the Cloud Access Security Broker, right? Or Cloud Security Access Broker, CSAP. This is one of the organization's security protections for cloud computing applications. Basically, it is a set of software tools or services that resides between the enterprise on-prem infrastructure and the cloud provider infrastructure. So kind of like creating that isolation between these two, right? It acts as a gatekeeper, makes sure even if the cloud is not in compliance with the security policies you apply within the enterprise on-prem, those are going to get applied to the data that you extend and save into the cloud, right? So basically, that's the role of CSAP. Just sits between two environments and makes sure applications are securely communicating. Then you have the security virtual device solutions. You can use a next generation secure web gateway, or SWG, which examines both incoming and outgoing traffic and performs basic URL and monitoring in web applications. If you refresh your memory with what we learned before, this is doing the job of the new generation firewalls, right? We had the new generation firewalls before. So go back to module 7 if you don't remember that and watch that video. So then you also can use a cloud firewall, which is a virtual software that functions very similar to an actual physical firewall. And we already have discussed it. It can be a static firewall, dynamic firewall, and a stateful and a stateless firewall that we had before. So you can have that in the cloud. One of the issues that make understanding cloud computing and security is just a little bit more difficult than a normal network is there is not a widely adopted model available to learn cloud computing, something like the OSI model, right? The 7 layers that we talked about before. However, one of the most famous models in cloud computing is what you can see here. We start from the bottom: physical layer, virtualization software layer, software-defined data center layer, native service layer, and application experience layer. So these are like similar to the OSI 7 layers that we used to have. And through this, we can explain and understand and evaluate cloud and cloud security a bit better. So for physical infrastructure, buildings, power cables, hardware, utilities, connectivities, media, all of those fall under that. And it's managed by the cloud provider. Virtualization software that virtualizes the hardware. This is including the hypervisor and virtual machines. Again, the cloud service provides this and maintains that. Also, we do have the SDD, or software-defined data center. It creates the infrastructure. Basically, that's what the SaaS, PaaS, and IaaS are created. And again, in case of a SaaS, as we discussed, everything is done by cloud computing provider. In case of a PaaS, or platform as a service, application is done by customer. And in case of a IaaS, application and operating system is done by customer. And then finally, we have the native service and application experience, which both are done by the customer, right? So this is a shared responsibility model. And as you can see, some of it is your responsibility, some of it is the cloud provider responsibility. Even though, even like in SaaS, that everything from IT perspective is provided there, you still are responsible for native service and application experience, which is done on your side. So let's stop here and do a knowledge check. So I really like to see many answers for this one. Which cloud security control provides reliability and resiliency through the duplication of the processes across geographical areas?
C.
Everybody agrees with that, using regions and zones? It was actually giving itself up, right? Talking about geographical areas. Good job. So, any questions so far? Shall I move forward? We good? Okay, guys. So let's start talking about the basis of cloud computing. So the whole idea of the cloud computing is to provide an interface to virtualize the underlying infrastructure into just one unique infrastructure, one unique system for the user. So user can easily look at it as they have their own computers in front of them, right? So virtualization security involves an understanding of the topic along with the specific examples. It includes the specific steps to be taken to secure a virtualized environment. First one is understanding virtualization. Since this has been discussed before, we're going to go through it quickly, right? So virtualization is a means of managing and presenting computer resources without regard to a physical layout or location. And that's what you have in cloud. When you go to your Facebook page, which is a cloud application, you really don't care about where the physical information is, how the connectivities are behind the scene, right? And that's the virtualization. Usually this happens through a hypervisor, which is running on a host, right? And then creates an interface which simulates a software-based emulation of a computer. Okay, what does it talk about? So if you look at this one, we do have a hardware at the bottom, right? On top of it, we have a hypervisor. Hypervisor and hardware together emulate different instances so that different guest operating systems can sit on top of them, and then applications can run on top of the guest operating systems. So as you can see, hypervisor is virtualizing, in this case, hypervisor is virtualizing the hardware. There are two types of hypervisors, type 1 and type 2. As you can see, type 1 virtualizes the full hardware. Type 2 virtualizes operating system and hardware together. That means type 1 hypervisor gets installed directly on the hardware, on the hard drive, before the operating system even is decided to be installed. While type 2 is installed on the operating system, like you have your Windows up and running, and then you go ahead and download, let's say, the VirtualBox or VMware or any of those, like for the Mac guys, the Parallels desktop is an example of that. And you install it on the host operating system. Of course, as you can know, type 1 hypervisor is more effective. It's faster and more efficient because it is right on top of the hardware, right? While type 2 is going through the host operating system and going through the hardware. As you can see in this one, in type 2, for an application to gain access to hardware, it has to go through one OS, then hypervisor, then a host OS, and then a hardware, which is going to decrease the power and decrease the performance that you can get. Another model that we use in virtualization is using containers. A container is basically a collection of everything that an application needs in order to run properly. What we do is we package them together, and now we have a container. So it's a combination of the application, binaries, which are the executables, the libraries, which are needed for the application, and underlying engine. So what we do is we have a hardware, we have a host OS. On top of it, we install a container engine. And on top of this container, we're going to have isolated containers that they actually have whatever is needed for that application. Think about this example. When you go to buy a tree from a nursery, you have these trees which are installed in a huge, which are planted in a huge box. The box has the soil needed for the tree, right? It has environment needed for the tree, and the tree and roots and everything are in that box. So basically, you can just pick up the box and take it home. Now you have a tree, regardless of any need to the nursery. In this case, hardware, host OS, and container engine together are the nursery. And then you have the pot here, the tree pot, which you take it. Did I say tree box? I think so. Then you can take this tree box or tree pot home and just install it on top of your container engine, which is your garden soil. And it's going to work. So using containers is becoming more and more popular because in this case, application and all what application needs to continue working can be super portable. Instead of going and installing a sophisticated application with a lot of steps to be taken and a lot of errors to happen, you can just download the container of that application and run it on your container. One good example of such environment is the Docker environment that you can install in your system. For those of you who are interested, you can go ahead and download this freeware called Docker Desktop. Actually, right now I'm running most of the applications that I use for my classes from the Docker container, so that each term I can simply just delete them, drop them out, and just create a new Docker, or just copy a new Docker from my archive to the actual Docker desktop where I will be using it for the duration of that period. So it's a kind of like very neat concept, and is very useful when it comes to using multiple applications on the same system. So there are some advantages that come with virtualization automatically. Of course, they can reduce the cost because now you don't need to have multiple servers, server hardware available. If you have a good hardware, you can just break it into multiple servers, or if you have 2 or 3 servers, you can just load balance between all 3 of those, depending on what service needs more load, and therefore reduce the cost. That means you need fewer computers for your physical computers to run the same thing, right? Also, they can provide uninterrupted server access. So if any of these servers fails, virtualization is still having enough underlying operating system and hardware available to it, so that the container still is going to be running, the virtual machine still is going to be running, and therefore you have more reliability, right? So next thing we want to discuss is software-defined network, SDN. Don't let the name scare you off. When you are virtualizing the environment, everything is virtual. When you have multiple, let me go back to this slide. When you have multiple of these containers, and these containers supposed to work with each other, right? They technically are networking, right? They have a LAN, they're communicating, they're sending and receiving information. There is no physical device to govern this, right? So what's going to take care of that is a software-defined network, a virtualization of a physical network, right? SDN virtualizes part of the physical network so that it can be more quickly and easily reconfigured when you change the VMs. When you drop a container out and put another container in, it automatically gets connected and goes through the network. You don't need to do anything about the configuration because SDN is taking care of it. This is accomplished by separating the control plane from the data plane. right? Traffic needs to flow through the network. It receives permission from the SDN controller, which verifies the communication is legit. And then if that is legit, the SDN controller computes a route for the flow to take and adds an entry for that flow in each of the switches along the path so that it can go between different physical computers, sorry, to reach to the destination. So SDN is required when you are actually virtualizing your environment. Without that, the virtual environment, especially when you have multiple physical underlying structures, is not going to work. We also have the software-defined visibility, or SDV, which is a framework that allows users to create programs in which critical security functions can be automated. So this is like a scripting that you do in a physical network. SDV allows network administrators to automate multiple functions in a network infrastructure, like dynamic response to detected threat patterns. If you remember, this is a job that SIEM and SOAR used to do in a physical network. Adjustments to traffic mode configuration for inline security tools, stuff like packet capture devices and all that can be used under the SDV installation. And also additional IT operation management functions and capabilities are available through SDV. So SDN and SDV are in place to mimic the physical network while everything is virtualized. So you still can have the same functionalities within a virtualized environment. So there are some security related advantages for virtualization. First is you can test latest security updates by downloading on a virtual machine before installing on a product computer. Why? Because these machines are isolated. These machines are not the real machines. These are virtual. You can install the updates, and if you break it, you just delete the virtual machine. That's the remedy right there. Just delete it, toss it out, and you're good to go, right? You can have a snapshot of the state of virtual machines, like if you want to do something that has multiple steps, like you want to install and configure a service, what you can do is you can take a snapshot after each successful step, so that in case of a problem, you just revert back to it, right? That's a good thing. Or you can share it with somebody else for a diagnosis or review. You can test anything within the realm of virtual machine. If there is a new virus or a new Trojan and you want to see, okay, how does this thing work? You want to study the behavior of this malware. Virtual machines are the best place, right? Just throw it in there. Technically, it's a sandbox, right? And execute it in there so it cannot it cannot exit and affect your actual machine, which is important, right? Worst case scenario, it fully takes over your virtual machine. You're going to delete it and copy from the source another virtual machine and move forward, which is making it easy. However, remember, if the isolation between the virtual machine and the physical machine is not perfectly configured, which is a misconfiguration from the user or administrator, then this advantage can turn into a disadvantage, because now the malware can lurk out of virtual machine into the actual machine, right? So not all hypervisors have the necessary security controls to keep out the attackers. Remember that. So this is really important, because I've seen people who fully believe in virtual machines, who fully trust virtual machines, but they're not necessarily best configured, so they can cause issues as well. Existing security tools were designed for physical servers, not for the virtual machines. Therefore, when using those, you need to be careful and put different characteristics of virtual machines into consideration to be able to evaluate properly. Newer tools like Tenable tools, Nessus, actually, that's what I'm talking about when I say Tenable, or Forescout, Silent Defense, and all of those goodies out there. Those tools are customized and built for working with virtual machines. And in case of using those, you can be a little bit rest assured about the results and how the tool actually is going to work on a virtual machine versus the physical machines. So VMs must be protected from both outside networks and other VMs on the same physical computer. That's the concept that we have in a normal network as well, because no matter what, you don't want different machines, whether physical or virtual, be able to attack each other as a foothold of a bad actor. So that's the same thing, right? Virtual machines may be able to, the VMs may be able to escape from the contained environment and directly interact with the host OS, which in this case is like a raw virtual machine. In that case, it is important to have the escape protection so that they cannot escape the container and start directly talking to the host operating system. Because remember, if I go up, as you remember, the virtual machines that sit on top, they cannot directly talk to the host. They have to go through the container engine. Or in this case, right, there's these virtual machines, they cannot talk to the host OS. So if any kind of bridge happens, which goes around the hypervisor or the container engine or container Docker desktop or anything like that, then you are in big problem because the virtual machine escape has happened. So you have to make sure the configuration is in the right place. Virtual machine sprawl is the widespread proliferation of VMs without proper oversight or management, as we discussed, right? So you have to be careful of that and avoid that from happening through setting the virtual machine and hypervisor correctly. As you can see, a lot of time in this one, I'm going back to the proper configuration management and proper configuration to be in place. So knowledge check, guys. Let's see who answers this one. What virtualization technology separates the control plane from the data plane on networking device such as switches and routers?
E.
Anyone else?
SDN.
Oh, you guys
5G
have been
use
listening.
SDN.
Yeah, you guys have been listening. Good. So the answer is SDN. Yes. So that is all we want to talk about when it comes to virtual machines and cloud computing and the security concerns associated with those. However, anytime we talk about any of these things, we are talking about the network protocols. We're talking about the communication over network. So it's good to understand and get familiar with a couple of secure network protocols, which are known to be better choices to be used, especially when it comes to virtualized environment, okay? So we're going to talk quickly about SNMP, DNS, FTP, all the secure email protocols, and LDAP and IP version 6, which has security built in. So SNMP, or Simple Network Management Protocol, is used to manage network equipment, and it's supported by most network equipment manufacturers. If you're running any kind of SIM, SOAR, or any kind of ICMP automation or scripting and all that, you need to have SNMP in place so that you can actually use the remote monitoring or remote configuring or remote management of a network, right? That's what SNMP gives you. So each SNMP managed device has an agent or a service which listens for and executes the commands that you remotely send to them. Agents are password protected, hence they are way more reliable than Telnet, protocols like Telnet, who actually are not password protected, right? And in this case, the password is called community string. Just learn the new jargon. Security vulnerabilities were also present as SMNMP version 1 and 2. Version 3 uses username and passwords along with encryption to address those vulnerabilities. Remember, version 3 is better than 1 and 2, but you never know which vulnerabilities are associated with it before you check Meyer.org and see, hey, what are the known vulnerabilities about this guy as of today? We also have domain name system security extensions, or DNSSEC. is usually the victim of attacks itself all the time. Attackers usually love to attack this because then they can do ARP poisoning, they can do DNS poisoning and all of those attacks in this one, right? So two major attacks known are DNS poisoning and DNS hijackings. These are the most popular attacks for the bad actors. They're simpler than the others and more effective than the others, especially if the system is not configured properly. Okay. So it adds additional resource records and messages headers information, which can be used to verify the request that data has not been altered in transmission, which is good. So basically you have additional controls in place to make sure what you received is secure. Using asymmetric cryptography, a private key that is specific to a zone is used in encrypting a hash of a set of resource records, which is then used to create the digital signature to be stored in the resource record. Remember, we are within the same enterprise network, so negotiation of private keys is way easier than the broad internet, and therefore we can leave with it. However, the traffic is moving between 2 points. It can be sniffed, right? It can has its own problems. It can has a man-in-the-middle attack, right? Or man-in-a-browser attack, those things that we discussed before. That's why, as you can see, asymmetric cryptography is being used here with the licensed server most of the time owned and managed by the enterprise. In this case, we call it a self-signed license. So FTP, file transfer protocol, also is a protocol that is being used, but it's unsecure, right? It used to connect to an FTP server in order to transfer files in the past. Those of you who are like my age, you remember that most of these websites that people download the stuff from, back in the day, they used to have an FTP site as well, but using an FTP client, we were just able to drag and drop the files into our computers and download from those. It can happen also through a command prompt, not only a web browser. And there are many vulnerabilities associated with this guy for one good reason. This guy doesn't have no encryption. So if somebody has the link to FTP site, they can simply just go to the site and then they're going to have everything in there. Also, when the file is being transferred, man-in-the-middle attacks can happen very easily as there is no encryption stopping the attacker. There are two options for secure transmissions over FTP. One is FTPS, which uses SSL, secure socket layer, or TLS, transport layer security, to encrypt commands sent over the control port, and the port uses 21. You don't need to memorize these, but after working a while with these guys, you are going to memorize those. For those who want to take the CompTIA exam, you need to memorize these. They're going to question you for that. I'm just talking about those who just want to go to the job market with the knowledge. Data port 20 may not be encrypted. That's why we use 21. You also have secure FTP or SFTP, uses only a single TCP port instead of 2 ports, and all data and commands in this case are encrypted. So that's kind of preferred over the other one. Email these days is one of the major concerns when it comes to enterprise information security. Earlier email systems used 2 TCP/IP protocols to send and receive messages. To send a simple mail transfer protocol, SMTP, and to receive the post office protocol or POP. You may have heard about POP3 protocol whenever you set up your accounts. That's a version of POP. IMAP or Internet Mail Access Protocol is a more recent and advanced email system. Like some of the known clients, like the mail application on your iPhone, it automatically by default tries to use IMAP unless IMAP is not supported by the other party, by the server you're using. As a means of security, a mail gateway monitors emails for unwanted content and prevents these messages from being delivered. Most of them are being delivered to a specific folder, so you can review them later, unless the mail server decides that, hey, look, my IMAP is not going to deliver any message that comes from specific address, IP address, email address, region, or stuff like that. So the mail gateways can automatically and transparently encrypt outbound email messages, not necessarily all of those, right? Like one of the mail gateways, which is very widely used in the business, is called Mailman. Version 1, version 2, and version 3 are out there. Version 1 and 2 were not able to accept any kind of encryption. And it's funny for you to know there are some enterprises in the very same state that we're living right now that are using Mailman version 2. And these are making those vulnerable, right? So not necessarily every protocol that you see is able to encrypt the incoming and outgoing messages. Next, we want to talk about the LDAP, a directory service. You guys all have seen it before in your networking class, right? As a database stored on the network that contains information about users and network devices. A good example is Microsoft Active Directory. The directory service also keeps track of all resources on the network and a user's privilege to those resources and grants or denies access based on the directory service information. This is similar to what you know as ACL. So LDAP makes it possible for almost any application running on any computer platform to obtain these information from the directory. A weakness of LDAP is that it can be subject to LDAP injection attacks. This may allow an attacker to construct LDAP statements based on user input and statements and basically impersonating and gaining access to the resources that the attacker should not have access by default. The defense against LDAP injection attacks is to examine all user inputs before processing. So basically, we need to do input validation before we process the request for LDAP. Remember, we had the same issue with SQL. So SQL or SQL injection was the same story. And we were saying, hey, the defense against it is to validate the input before we actually execute those. So if you miss that validation step, then you're going to enable the attacks and the attacker can take over the security. So IP version 6, which you hear a lot about it, remember IP version 4 is so old. When IP version 4 was generated, it was generated without security in mind, and it's going to be funny to know, even without multimedia in mind. So that's why there are a lot of other assisting protocols helping IP version 4 in order to be able to work with multimedia. But then IP version 6, which is not yet widely, and I mean, it's not widely used, right? Internet is still based on IP version 4. But internal networks are taking over IP version 6, and very soon I believe it's going to be a spread to the entire internet. That is there to address the weaknesses of version 4, all the weaknesses, right? And also provides other significant improvements, such as being able to address many more hosts, because we already are running almost out of all IP version 4s in the world. But IP version 6 can never be all consumed. Even if on every square inch of the planet you have a computer device, still you're going to have enough IP version 6s available. So it has enhanced security features because it can implement end-to-end encryption within the protocol, which makes man-in-the-middle attacks significantly more difficult and almost impossible for lower than grade hackers. IP version 6 supports more secure name resolution. So basically, through using the secure neighbor discovery or SEND, it can send cryptographic confirmations that an endpoint is who it claims to be. So basically, like within a neighborhood, every neighbor knows their neighbors. And then you can have a chain of trust between these neighbors that each one can actually confirm the identity of at least one neighbor for the other neighbor, right? The left side neighbor for the right side neighbor. That's how it works. Through something similar to that, IP version 6 provides a better identification, something that IP version 4 does not have. This makes ARP poisoning more difficult because now you cannot go somewhere and say, hey, I am who I say I am, without a neighbor supporting your claim. And that's what makes it more secure. Let's do a knowledge check. Which type of networking service is potentially susceptible to LDAP injection attacks?
D.
Mail service. Any other input? So note that LDAP stands for lightweight directory, blah, blah. So any change in your idea?
I guess it would be A then.
Okay, let's see what survey says. Survey says A, directory service. Lightweight Directory Access Protocol, or LDAP, is a protocol for using and maintaining directory services, which is a database, as I said, like Active Directory, that stores is stored on a network that contains information about users and other network services. Cool. This is all what we want to cover in this one. Let's quickly go through the summary and see what we did. We talked about cloud computing. We said it's a popular and flexible approach to computing resources. A public cloud is one in which the services and infrastructures are offered to all users with access provided remotely through the internet. On-premises is computing resources located on the campus of the organization or enterprise, while off-premises is computing resources hosted and supported by a third party. Usually an enterprise, we refer to them as on-prem and off-prem. There are many elements that make up a cloud architecture: a thin client, transient gateway, serverless infrastructure, and such. Cloud computing service models include software as a service, platform as a service, infrastructure as a service, and anything as a service. Again, guys, don't let these fool you. You're going to hear a lot. What you want to focus on is software as a service, platform as a service, and infrastructure as a service, which any other service can fall under one of these categories. Cloud computing has several potential security issues that we discussed. While securing the functional areas of the cloud is important, an area often overlooked is application security or protecting applications. Virtualization is a means of managing and presenting computer resources by function without any regard to their physical layout or location. Instances of virtualizations are sometimes referred to as infrastructure as a code. There are several secure network protocols that are used today: SNMP, DNWCC, FTPS, SFTP, and such. Electronic mail systems that are in use today are SMTP, POP3, and IMAP. With that being said, we've finished this recording.